In the last video, you saw how to look at the equation, figure out what the vertex is, figure out if it's concave up or concave down, and then see what that would look like on a graph. So we were just trying to connect equation in vertex form to graph. In this video, we're going to be doing something called translations. That means how did the parabola, remember that means the U shape, how did that shift locations or change locations from my original function? So for that to make sense, I need to tell you what my original function is. The original function is often called the parent function. So think of like in a family how the kids probably look kind of like the parents but different. Same idea with the parent function. The parent's the original one, and this is actually our parent function right here. The original one with nothing fancy happening to it. This is just a basic quadratic, x squared. Okay, that's the parent function. And then the parent's going to have babies, and then the babies are going to still kind of look like the parent, but be a little different. So they're still going to be a parabola shape, but they're going to be in different locations. So we're trying to figure out, well, how does the vertex tell me how my parabola will translate from my parent function? Okay. So one thing that I want to talk about is what translating means. So translating means shifting. So you can shift right, you can shift left, you can shift up, and you can shift down. Those are the different directions you can shift. Now let's connect this to a graph. So you have the x-axis and you have the y-axis. Which axis usually goes with moving right and left? Hopefully you're thinking about the x-axis. Which axis deals with moving up and down? Hopefully you're thinking, oh, the y-axis. Okay, so because I have a vertex of 0, 0, I'm not shifting right or left at all for this parent function, and I'm not shifting up or down at all, which is why my parent function has a vertex at 0, 0 on the origin. We're going to compare everything back to this function. So this has no translation. It's not moving right, left, up, or down. Let's look at our green function. So x squared plus 2, we said has a vertex of 0, 2. So what that means is I'm not shifting right or left at all, and I should be shifting up 2 because that's a positive 2, and that 2 matches with my y. If I look at the picture, do you see how my green parabola is just like my parent function, my black one, but I shifted it up 2, moved that vertex up 2, the whole thing moved up? So that's the translation that I have from the parent function for this green one. The translation is just up 2. Okay, let's look at the red one. So this one is negative and then parentheses x minus 1 squared. So here we have an x value of 1 and a y value of 0 for our vertex. So because the x is 1, that means a positive 1. So you can see I shift from my parent function to the right 1. And then because the y value is 0, I'm not shifting up or down at all. So that's why the vertex only just moved 1 to the right. And then I also have a negative out front. So that means that my parabola is now going to be concave down instead of concave up. That's the reason why this is facing a different way. So when we go back and compare to the parent function, how did it change? Well, it shifted 1 to the right, so right, 1, and how else did it change from my parent function? It flipped upside down. So I'm going to say it flipped. Okay, now let's look at our last one here. So this had a vertex at negative 3, negative 2. If I compare that to how my x and y axis shift, that negative 3 would tell us left 3, and that negative 2 would tell us down 2 because that goes with the y value. So if I compare that to my parent function, which is right here, see I'm moving left 3, 1, 2, 3, and then I'm moving down 2, 1, 2. So for my translation, I'm going to write left 3, down 2. And then this one did not flip upside down the way that my red one did because I don't have a negative out front of my parentheses. So hopefully now you can understand how moving the vertex translates our parabola from the parent function.